So in this section, we're going to talk about graphing our trig functions. Today we're going to start with sine and cosine. Right, there's a couple of things we're going to have to do before we get there. We're first going to graph in radians. Okay, so what we're going to do is I'm going to make a chart of all the radian measures we should know. All right. Now, if we don't know them, that's okay. But remember, you can always convert by multiplying by pi over 180. So that's where I'm getting these numbers from. So if I want to change 30 into radians, it's 30 times pi over 180, and that's pi over 6. So we all know 0 is 0. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. And pi over 3 is 60 degrees. Important one we definitely should know is 90 degrees, which is pi over 2. Now, these are where they get a little more complicated. 120 is 2 pi over 3. 135 is 3 pi over 4. 5 pi over 6. And 180, which is the other important one, is pi. Moving along, we have 7 pi over 6 is 210. 225 is 5 pi over 4. 4 pi over 3. And then 3 pi over 2, which is another important one for 270. And then our last one, 5 pi over 3, 7 pi over 4, 11 pi over 6, pi, and 2 pi is one complete rotation. Now there are important numbers we definitely need to know. Alright, where was I? Where the last train of thought. So, back to this. We're going to plug in our values. There's some ones that we definitely should know, and they're very important. We should know that what the sine of 0 is. And if we remember from our unit circle, the unit circle, if you plug in, it's the y-coordinate. At 0 degrees, the y-coordinate is 0. At 90 degrees, it's 1. 180 at 0. 270 is negative 1. And 360 is 0. I'm using degree because we're so used to that. But remember, we're going to be graphing this in radians, and I'll tell you why soon. So, these we should know from our chart. This is 1/2, radical 2 over 2, and radical 3 over 2. However, when you graph, you're going to need the decimal equivalents. So I'm actually going to find out what the sine of 30 is. Well, it's easy for this one. It's 0.5. Radical 2 over 2 is 0.7071. We did that. If you plug in that in your calculator, but it's just 0.71. And then if I do radical 3 pi, or sine of pi over 3, which is the sine of 60, it's radical 3 over 2, that's 0.86. Okay, those are our values from our chart. Now, if we're in quadrant 2, we should know that in Q2 we should be positive. So all these numbers are going to be positive. Well, this right here, 120, is the same as the sine of 60. It's 0.86. It goes in reverse order, 0.71, 0.5, and 0. From here, we're in Q3. We should know that those angles are all negative. So now we go negative. 210 is the same as we do 180 minus the sine of 30, 0.5, but it's negative. Then it's 0.71, 0.86, negative 1. The last thing is our final thing in quadrant 4. Again, Q4 is negative. But now if you do 300, that's the same as 60. 60 is 0.86, but it's negative. 7 pi over 4, which is 0.71, and 0.5. So this is our table of data. We're going to graph this, and it's important to see we're going to use, what we're going to do is we're going to do it in terms of 30 degrees or pi over 6 radians. Because if I look at this, pi is 3.14. Well, the height of this only goes up to, the highest is right there, and the lowest is there. So I need the x to go up only to 1. So if I did if I did 360 degrees, I'd have to go from 0 to 360, which is huge. But if I go 2 pi, that's 6.28. So 0 to 1 up and 0 to 6.28 is a much better idea. Okay. So to do it evenly, we're going to go up by 30 degrees. So we're not going to be using the 45s, but we should know them anyways. You see me cross them out because we don't want to put them on our graph. We can approximate them, but we should be able to do without it. All right. So the next thing we have to establish is when we graph sine of x, is that we want 3 blocks to be pi over 2 because it's 30, 60, 90. 1, 2, 3. Then another 3 blocks for pi. Then 1, 2, 3 more blocks for 3 pi over 2. 1, 2, 3 blocks is 2 pi. And this is why I said it was important for us to go by those 90s and to know those values. Okay? We took the sign of 0. The sign of 0 is 0. The sign of 30, which is pi over 6, is 1/2. Now we're going to go half and then 1 up. Okay? That's a half. This is sine of 60, which is pi over 3, which is going to be 0.86. So it's a little bit above the half mark. And then the sine of pi over 2 is 90. Sine of 90, which is 1. So you can see there's the first half of my sine. Well, now it's going to go in the reverse order. 0.86, 0.5, and then back to there. So if I start graphing that, you're going to see it's going to make that hill. Well, now it goes negative. So 210 is 0.5, negative 0.86, negative 0.1, negative 1. Okay, below the axis. Then it rebounds up, and we go back to 2 pi. So if I graph this, I draw my line through it. And as you can see, it's tough to graph. I don't like that. So be careful. You want it to be a smooth curve. So there we go. We have that right there, and if I just kind of get rid of my first one, I think that's the one I liked. It doesn't be dropping things on toolbars. And if you look, that's a little better. Okay. And there's our curve. That is our sine curve. Notice the high point, the roots, and the low point. Okay. Well, if we do the other half of this, we're still going to stick by 3 of these, but now we're going negative pi over 2 because we want to continue with our pattern. Then 1, 2, 3 is negative pi. 1, 2, 3, negative 3 pi over 2. 1, 2, 3, negative 2 pi. Well, think of this. Well, right here, this is from 270 to 360 because it's negative. Remember those angles are in quadrant 4. It's literally the copying of that half of the curve. So there's the point there. Negative pi is 0. There's negative 3 pi over 2, which is the same as 90. And then negative 2 pi is the same as 0. See how I only put those 4 points? But if I look at those 4 points and draw a nice curve through it, you can see I have another wave. And this is going to repeat every 2 pi because, think about it, the unit circle goes around every 360 degrees, so it's going to repeat in the same pattern. Okay? And there's our sine curve. Our domain is from negative infinity to infinity. This is because it goes on forever, and think about it, can you take the sine of anything? Of course you can. Now if I look at the range, that's the high and the low, that's between negative 1 and 1. And you can include them. You can't have signs that can be bigger than 1 and negative 1. Alright? Now, if I start putting numbers in front of sine, 3 sine of x, you're going to see we're going to take these values and multiply them by 3. So you're going to see a little bit of a change. Just like if I put the 3 in front of the x, that's going to change the graph as well. Let's take a look at cosine. Cosine, oh, this is other stuff. Another way to put it is, it's the y-coordinate, remember? So it's at pi over 6, there's pi over 6 height. At pi over 3, there's pi over 3. And it's just translating them onto the unit circle, from the unit circle to the graph's height. So it's the height of it. As we go around, it goes over here. Right? So cosine, we're going to stick to using the same set of numbers. Okay? So knowing that these things right here are going to be important. So, cosine, we've got to be able to start by putting our graph together. So, again, we're going to use 0, pi over 6, pi over 3, or 4, pi over 3, pi over 2. Okay, those we should know. Again, the rest are a little more complicated. Just multiply by 2 pi, or multiply by pi over 180 to get them. See, I was doing it right there. 120 is 2 pi over 3. Is 3 pi over 4, 5 pi over 6, and then pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, and 3 pi over 2. And then the last set, 5 pi over 3, 7 pi over 4, 11 pi over 6, and then 2 pi. Now this is a little different. We're going to use cosine, and cosine's values we should still know, okay? Which if we look, cosine now of 0 is 1. Remember, it's your x-coordinate, 0 degrees. It's 1 over 0 up in the unit circle. Then 90 is 0, 180, we should definitely know our pi is negative 1. 270 is 0, and then 360 is 1. Notice how I put the highs and the lows. Those are the important ones. The rest, again, is just part of the unit circle. 0.87, 0.8, yeah, 0.866 is 0.87. And then the next one, if we put in, is 0.71, and then 0.5. Well, here, they're going to be negative. Why is it negative? Because unit circle, take a look at it. Negative 0.71, negative 0.87, or 8. Yep. And then here, quadrant 3, it's negative as well. Negative 0.7, negative 0.71, negative 0.5. And then it's positive in Q4. 0.5, 0.71, and 0.87. So now I want to graph these. If I graph them, it starts at 1. Oh, remember, pi over 2. 1, 2, 3 is pi. 1, 2, 3, 3 pi over 2. 2 pi. So if I graph them, you can see, there's my graph, and it ends up where I am at the start. Okay, we can graph the other half, and we're going to have to do that tomorrow in our next video. Take care.